Division of real numbers. A lot of times we can use our knowledge of the rules and properties of numbers to kind of manipulate them and make problems easier for us. And what we're going to see in division of real numbers is that we can use those skills to manipulate numbers and make the problems easier, but we also are going to see that the rules of division that we learn for integers or for rational numbers apply to real numbers as well. The first thing we need to review is reciprocals. It says for every real number other than 0, there exists a number called its reciprocal. Now, there is the technical definition of reciprocal that says if you multiply a number by its reciprocal, you get 1. Or there's the more simplistic version of it that just says, well, you just kind of flip it over. Here's what we mean by flip it over. The reciprocal of 13, we have to flip it over. Well, there's really nothing to flip over except we can write a 1 underneath. So the reciprocal of 13 becomes 1 over 13. If you look at 1/2 here, the reciprocal of 1/2, you just flip it over and you get 2 over 1. Now, that whole technical definition of if you multiply them, you get an answer of 1. If you look at this example here, if we took 1/2 times 2 over 1, we get 2 times 1, or 1 times 2, which is 2, and 2 times 1, which is 2, and it ends up being 1. And that's always going to be true for reciprocals. Okay, so however you want to think of it, just make sure you know what a reciprocal is. Again, -8, that becomes 1 over -8. Now, ladies and gentlemen, be careful with the negative. There only can be one negative. You can't put a negative with both the 1 and with the 8 because then it's no longer negative. 2 negatives equal a positive. But it doesn't matter if you wanted to put the negative on top. As long as this one negative, or even maybe out front, as long as there's just a negative, reciprocals have nothing to do with things becoming positive and negative. If it's negative, it stays negative. For example, this one here, we could write this, if we flip it over, as a -4/3, or -4 over 3, or 4 over -3. Okay, again, as this whole number here is negative, that's what we're after. Okay, and so basically it works for all numbers. The reciprocal of a is just 1 over a. The reciprocal of a over b is b over a. So let's see how we can use reciprocals to divide. We have our division rule here, which says to divide a number by a non-zero number b. Here's the reason it can't be 0. If you take any number and divide it by 0, not possible. So to divide a number a by a non-zero number b, multiply a by the reciprocal of b. So kind of like we had our rule from changing subtraction problems into addition, we have a rule for changing division problems into multiplication. So instead of saying dividing by b, you multiply by the reciprocal. And you really already know this rule because we use it for when we divide fractions, but it applies to all numbers. Okay? So if you look at the example here, -1 divided by 3, how could we rewrite that? We take -1 and instead of dividing by 3, multiply by its reciprocal. And you might think, why would we want to do that? Well, in some cases it really does make the problem easier. Let's look at some examples. If you find the quotient of, find the quotient. We have 5 divided by -5. Don't think that that is a totally different problem. 5 divided by -5 is still going to be -3. But if we want to think of it in terms of multiplication, we can rewrite this as 15, instead of dividing by -5, multiply by the reciprocal. The reciprocal of a -5 is a -1/5. And if you wanted to multiply it like this, you could use your cross products and say, or cross reducing. 5 goes into itself 1 time, 5 goes into 15 3 times. 3 times a -1, don't forget there's a negative there. Doesn't matter if you put it on the top or bottom, but it is there. 3 times -1 is a -3, 1 times 1 is 1, and we end up with a -3. Again, for a problem like this, probably not very practical to change your division to multiplication. But it is practical right here. If you look at -45 divided by 5, 6, we can think of it as -45. Instead of dividing by 5, 6, multiply by the reciprocal of 5, 6, 6/5. If we kind of even out, or think of it as fractions here, we can use cross-reducing. 6 and 1 have nothing in common, but negative 45 and 5 both have a 5 in common. 5 goes into itself one time. 5 goes into a negative 45 a negative 9 times. Negative 9 times 6 is a negative 54. And if you look at the bottom, we just end up with 1 times 1, so we don't really need to write that on the bottom. Again, these are pretty common, simple problems you should already know how to do. But the bottom two here are ones we need to focus on, because these are the type of problems we're going to start seeing. If you look at 2 1/3 divided by a negative 3, it's kind of hard to figure out what we're doing. Basically, we're going to take this 2 1/3 and we're going to break it up into, well, 3 groups, but it's going to be negative. So a couple things we need to do. First of all, don't ever try to divide without making it into a improper fraction. So we do that by going 3 times 2 and getting 6, and adding 1 and getting 7. So this is like saying 7/3 divided by a negative 3. Thinking about our rule for changing division into multiplication, we take our 7/3, instead of dividing by a negative 3, we multiply by the reciprocal of a negative 3. Be careful. That doesn't mean we multiply by negative 3. We multiply by 1 over a negative 3. By doing that, we can go 7 times 1 and get 7, 3 times a negative 3 and get a negative 9. Can we reduce that at all? No. So that's our answer. Okay. That negative doesn't matter where you put it. You could have a negative 7/9 here or a negative 7 over 9. Okay, just as long as this fraction is negative. Look at the last example. We have negative 1 divided by 2/3. Okay, again, we take our negative 1 and instead of dividing by 2/3, we multiply by its reciprocal. Well, its reciprocal is 3 over 2. If you multiply that out, well, negative 1, if you remember our properties from the other day, negative 1 times 3 over 2 just becomes a negative 3 over 2. It is totally acceptable if you leave it like this. In fact, most of the math you do now, we will not deal with mixed numbers, even though there is one given here, just because we always change mixed numbers into improper fractions before we can do anything. If you were to make this into a negative 1 1/2, that would be fine, but don't feel you have to. Negative 3 over 2 is perfectly acceptable.